Video 1: Solar Energy Introduction. Today more than ever, our society is seeking ways to live efficiently. 93 million miles from Earth is the source of virtually all the energy on Earth, the Sun. It powers plants and the animals that feed on them. Although we barely tap into this immense energy resource, that won't be the case forever. With fossil fuel supplies like oil and coal on the decline, the sun will become our primary source of energy. Most young readers will see the day when solar and wind energy become the dominant source of energy. In recent years, rising concern over the high social, economic and environment costs of global warming has stirred intense interest in renewable energy, especially solar energy. Interest in solar and wind forms of renewable energy has also increased due to the concern over declining fossil fuels, especially oil and natural gas. These concerns in turn have created favorable policies at the state and national level that are making it more affordable for many businesses and tens and thousands of homeowners to install solar energy of all types. This video training series focuses on one particular type of solar system, the solar electric system for homes and for businesses. They are also known as photovoltaic systems or PV systems for short. An overview of the solar system. As their name implies, solar electric systems convert the sun's energy into electricity. This conversion takes place in solar modules, also commonly referred to as solar panels. A solar module consists of numerous solar cells. Solar cells are made from one of the most abundant chemical substances on Earth, that is the silicon, a component of sand and quartz that also make up much of Earth's crust. Solar cells are wired together and encased in plastic and glass with a metal frame to create solar modules. The plastic and glass layers protect the solar cells from moisture. Two or more modules are typically mounted on a rack and wired together. Together, the rack and the solar modules are referred to as the solar array. Electricity generated by a PV array flows via wires to yet another component of the system, that is the inverter. The inverter converts the direct current electricity produced by the solar cells into the alternating current AC electricity commonly used in US homes and businesses. In this training, I'll focus on residential, small business sized solar electric systems whose rated power typically ranges from 1000 to 10,000 watts. Rated power. So what is rated power and watts? Rated power is the instantaneous output of a solar module measured in watts under standard testing conditions. Watts is a measure of the rate of flow of energy. It is used to rate the devices that consume electricity. For example, a 100-watt light bulb and a 1200-watt microwave oven. This number describes the amount of power a device consumes. Watts is also used to rate technologies that produce electricity, such as solar modules and wind turbines. You might, for instance, install a 3000-watt solar system on your home. 3000 watts is what is called the rated power, the rated output. Most residential solar electric systems fall within the range of 1000 to 6000 watts, that is 1 to 6 kilowatts. 1000 watts is equal to 1 kilowatt. Although PV systems as large as 9000 or 10,000 watts are sometimes required for very large homes or businesses. It's important to note, however, that the output of a PV system doesn't mean the system produces that much electricity at all times. Example, a 3 kilowatt PV system, for instance, won't produce 3000 watts of electricity all the time when the sun is shining on it. It only produces the amount under standard testing conditions. Applications of a solar electric system. Once a curiosity, solar electric systems are becoming a commonplace even in less than sunny areas such as Germany and Japan. Germany and Japan are the largest markets of PV modules in the world. While many solar electric systems are being installed around the world to provide electricity to homes, they are also being installed in schools, small businesses, and office buildings. Even skyscrapers like the Times Square in New York City, the home of the Nasdaq, and many large corporations such as Microsoft, Toyota, Google have installed large solar electric systems. Even some colleges and airports are installing PV systems. Solar electric systems is proving to be extremely useful on sailboats. Their small PV system often power lights, fans, radio communications, GPS systems, and refrigerators. Many recreational vehicles, RVs, are also equipped with small PV systems to power microwaves, TVs, and satellite receivers. And even many bus stops and parking lots are illuminated by solar electricity, as are portable information signs used at construction sites. Also, numerous police departments have solar powered radar units in their neighborhoods to discourage speeding. These units display the car's speed and warn drivers if they are exceeding the speed limit. Few terms and their differences. Power and energy. So what's the difference? The terms power and energy are frequently used but often misunderstood. In the electrical world, power is measured in watts or kilowatts. Power is an instantaneous measure like the speed of car. In the electric world, power is a measure of the rate of flow of energy. Engineers and scientists rate electrical loads, which are devices that consume electricity, such as the light bulbs, electric motors, in watts or kilowatts. For example, an electric toaster might be rated at 1000 watts. Scientists and engineers also use watts, as noted in the text, to rate electric generator technology such as PV systems. A solar system, for instance, might be rated at 5000 watts. Since 1000 watts is 1 kilowatt, a 5000 watt system is also referred to as a 5 kilowatt system. Energy. Energy, in contrast, is a power consumption over a period of time, production over time. A light bulb that consumes 100 watts for 1 hour consumes 100 watt hour of electricity. If it operates for 10 hours, it uses 1000 watt hours of energy, or 1 kilowatt hour of energy. Both watt hours and kilowatt hours are measures of energy production and use. A solar electric system produces electricity at a rate of 1000 watts for 4 hours, that is 4000 watt hours, or 4 kilowatt hours of energy. Railroads, signals, and aircraft warning beacons are also often solar powered. While PV systems are becoming very popular in more developed countries, they are also widely used in developing world. There are a few instances being installed in remote villages in less developed countries to power lights and televisions. They are often installed to power refrigerators and freezers to store medicines. PV systems may also be used to power pumps to provide water for villages, and the ultimate in remote and mobile applications, however, has to be the satellite. Virtually all military and telecommunication satellites are powered by solar electricity, as is the International Space Station. So that concludes video 1, Introduction to Solar Energy. Thank you.